All right, today we're going to talk about this using similar figures, okay? But before we do that, we kind of have to review what it is that we were doing with proportions. Because the whole concept today is based on you solving a proportion, okay? And most of your test, which will be Monday, is going to be based on you being able to solve a proportion, okay? So being able to cross-multiply and solve an equation. So let's go ahead and just look at a simple proportion, walk through it. Okay, so let's say we have x over 4 equals 1/10. Okay? How would I start this? How would I start to solve this problem? What would I do? Okay, Isabella?
Cross multiply.
Yeah, absolutely. I got to cross multiply. So I'm going to go ahead and I'm going to multiply these two things. That's going to give me 10x. And that's going to be equal to 4 times 1, which is what? 4. Okay, so I have 10x equals 4. All right, what does that mean? Let's see, can I move up? 10x equals 4. How do I go about solving that? What do I do? How do I get x by itself? Yeah.
Divide everything by 4.
Divide everything by 4.
By 10.
Are you sure?
Yes, by 10.
Okay, it's by 10. Why 10? Yeah, Gabby.
Because
Because it's
it's connected to the x.
connected to the x. What is the whole point of solving an equation? What is the main focus? Yeah.
To get x by itself.
To get x by itself. Absolutely. So to get x by itself, I divide both sides by 10. Okay, what happens to these 10s? Yeah.
We cross out.
They cancel out. Really, what is happening to them? 10 over 10 equals what? What does it equal? 1. It equals 1. So this becomes 1 times x equals 4 over 10. Do we really need to write the 1 in there? I mean, anytime, no. No, anytime you multiply by 1, you don't really need to write it. So really, it's just x equals 4/10. Can I simplify 4/10, however?
Yes.
Yeah, what goes into both 4 and 10? 2. So 2 goes into 4 how many times? 2 times. And 2 goes into 10 how many times? 5 times. So the answer is 2/5 or 0.4. 0.40 would be the decimal. Okay? So that's how we solve proportions. Today's lesson focuses more on a geometry perspective, okay? So working with triangles mostly. So let's go ahead and take a look at that today. Right now on your paper, draw a triangle that looks something like this, okay? Then what I want you to do is I want you to draw a kind of a similar triangle, but make it just a bit smaller, okay? So 2 triangles. What's this little symbol in the corner mean?
Are you all right?
Yeah,
Oh, it's a 90.
it's a 90-degree angle. Okay? So these are what we call right angles. They're 90 degrees. I will also tell you that these here are the same angle, and these here are the same angle. Okay? And the smartboard's a little off, so we're doing the best I can here. What is the only difference? It's actually not calibration. It's actually the chip in this side of the board is fried. What is the only difference in these 2 triangles? The angles are all the same, but what? Yeah.
The size, one's bigger,
One's bigger, one's
one's smaller.
smaller. That's it. That's the only difference. We have a bigger triangle and a smaller triangle. If they have the same angles inside, they're what you call similar. We would call these 2 things similar figures. Okay, so what do they need in order to be similar? What do they have to have? What did I say? Yeah.
The same angle.
They have to have the same angles. If they have the same angles, they're similar. All right, and that's the key idea behind today's lesson in order to identify proportions. We look at figures and we say, are they similar? This is used all the time. Case in point. Look at these bridges back here. Okay, see these bridges? Let me grab one.
Bridges, I love bridges. Don't break it.
My students built these.
Can we build
So
some?
it's nothing aboard.
We didn't
Okay.
build them.
No, you didn't.
Others still did.
All right.
I saw the video.
This was designed on a computer. Okay, all of those bridges were designed on computers, and they were designed on a computer to be very small. Okay, how did a person, or how did my students get a very small picture on a computer to be a real life object to scale? How did they do it? What did they do? Yeah. No, 3D printers would do that, but 3D printing is not how they built this. They actually had to cut each piece, glue each piece to build these bridges. How did they do that? How did they know how to do that? Yeah. Okay. They had to basically keep all of the angles the same. Okay? They had to build this making sure all the pieces were proportional. So, you build something on a computer, and then you make all the measurements similar. You scale it up. Where do we use scale models at? Where in society do we use scale models a lot? Yeah, Isabella? Architecture, absolutely. Almost every building has to have a scale model designed so that people can see what it'll look like in 3 dimensions. Sometimes computers just don't do it for us. We actually want to be able to walk around, see how the light plays on the object, see how the shadows work. A good architect will set up lights in different spots to represent the sun moving through 24 hours a day, to see how the building will affect the surrounding buildings and landscape. Okay, that's how you design a good park, a good building, etc. Yeah, where else?
In art, you practice on a smaller piece of paper and then you get.
Yeah, absolutely. A lot of artists have, if they're going to do a sculpture or they're going to do a large painting, they'll make a small replica first, a small piece first, and then replicate it. A case in point would be a lot of statues. A lot of statues, you build a small one so that you can make sure all the dimensions are right, and then you scale it up. Okay? Parker.
If you go to there's an architect building,
Mm-hmm.
they designed the Yankees parking garage.
Okay.
You can see like other buildings they built for rain, like the scale model.
Yeah, so
Look through the windows and they look like real like toy buildings.
yeah, they look like toys, don't they? Because they're about the size of a toy. But they're real. Does anyone ever seen Lego exhibits? Like when they actually build Legos to look like a real building. Okay? Now go ahead and put your hands down. Yeah, it's really neat. This is how it works. They take a real life object which is much larger. They maintain all of the similar properties, but they scale it down so it's a lot smaller. Okay? Yeah.
What's the place where you go and you like learn about the fire? Safe house. Safety village, where they have all the little houses.
Oh yeah, and so the kind of like a little village, and then you can watch and yeah, I'm guessing, of course, but All right, let's get back to this. Let's go ahead. You've drawn your 2 triangles, right? Okay, draw 2 of the same types of triangles on a different part of the paper, and this time we're going to put numbers on them. Okay, let me go ahead and find my mouse here. Okay, this is what this is going to look like. I'm going to draw okay, these are really bad triangles, but that's okay. This one's going to be 3, no 3. This one's going to be 3 here, 4 here, 5 here. Does anyone know what the hypotenuse of a triangle is?
I don't even know what that word is.
Hypotenuse.
That's a good name of a dinosaur.
Yes. Not how tall. That's a great guess, though. Okay? There are 3 sides to a triangle. The hypotenuse is this one of the special sides. Okay? It's always the what side? Mr. Miller.
Obtuse.
It's an angle.
Width.
It's always the what side?
Right.
The longest.
The longest side. Okay? Hypotenuse is always the longest side. Okay. All right, so in this small triangle where it says 3, 4, 5, okay, what side is the hypotenuse? Yeah, the 5. Okay, now let's say I have a triangle that is 6 and 8 on these sides. Okay, I'm going to tell you these sides, or these two triangles, are similar, which means that the sides have the same proportions. The same proportions. So you see how 3 and 4 and 6 and 8, would you say that's proportional? 3 is to 4 as 6 is to 8. Okay? Do you see that or no? Take out your calculators. Take 3 and divide it by 4. And you get, Mackenzie, 0.75. Take 6 and divide it by 8. Yeah. 0.75. They're proportional. Okay? So 6 and 8 has the same proportions as 3 and 4. What's different though? They're proportional, meaning they have the same value. But what would you say is happening from 3 to 6 or 4 to 8? What's happening? Yeah. I'm multiplying it by 2. So if this was my little scale model, it, would you say a third the size? Half the size? Would you say that the scale model here is half the size of the original? A third the size? A quarter the size? What do you think? What do you think? 3 is what to 6? Half of it. So this triangle is half of this triangle in proportion. Okay? 6 divided by 2 is 3. 8 divided by 2 is 4. What would be the long side of this upper triangle then if these proportions hold true? Yeah. Okay, well let's take it, that was a guess. 2.5. Which means that this is double this. Right? Because 4 times 2 is 8, 3 times 2 is 6, 5 times 2 is 2.5. Is that right?
No.
I think we might be a little off. Maybe we went in the wrong direction. Okay, what would it be? Millie. It would be 10. Okay, but we've got some good things happening here. Yeah, it's 10. What we're doing in our heads right now is we're making proportions. We see that if we double all of these numbers, we get these numbers. If you can do that, the two objects are similar. Okay? Let me give you another example of this. Okay? We can come back to this if need be. Let me work through another example here. Okay. Let's say that I have these two triangles. And let's say that the sides are, I gotta think through them so that they're actually real life examples here. Let's say this is 2. Let's say this is hang on, let me give you the right numbers. 6. Let's go 6, 8, 10 again. Okay? But now I'm going to tell you that this triangle, this one here, is 36. That's all I'm going to give you. Okay? Well, can you figure out the other two sides? Can you figure out this side and this side using this information? I'm sorry, this is 32. I want to make it 32. Can you figure it out?
Wait, did you say that all have to be times the same thing?
Yes. Yep, they all have to be times the same thing. So the question is, if I'm going from 8 to 32, then what would this side and this side be? Gabby? Okay, that's fine. 32 divided by 8 is what?
4.
Okay, you're right, it is 4. So this one is going to be how much larger than this one? If I'm dividing by 8 and I get 4, this one's how much larger? Yeah, 4 times larger. So what would I do then with this information to find these two sides? Gretchen. Okay, that's excellent. So for the 6, I would do 4 times 6, and I would get what number? 24. Yeah, okay, so let's write that in. 24. Okay, and then what about this one over here? Yeah, Gretchen? All right, 10 times 4 is 40. And that's accurate. That's true. Okay? This is how we use proportions. Okay? This is how we do it. Now, let me show you how you would set this up mathematically. Let's say that we only know the following information. We'll start with one of my favorites here, 3, 4, 5. But now the triangle that we're going to is this one. Okay? The triangle we're going to here is 6 on this side. Okay, now we have an issue. Does 4 go easily into 6? No, it doesn't. But I do know that 4 and 6 are proportional, and therefore I got to figure out what would I multiply 4 by to get 6. Okay? This is how I could set this up. Let's say that I'm going to try to find this side here. It's unknown to me. I'm going to call it x. Most times when we don't know a number, we assign it a letter or a picture or some kind of symbol. Okay? Maybe it's the fish. Maybe it's omega, alpha, omega. Okay? But this time we're going to use x. I would say that the following. 3 over 4, so what I'm doing is I'm making a ratio here. I'm saying 3 over 4, this is a ratio of the smallest side to the middle side of the triangle. I'm comparing them, 3 to 4. So I'm going from small side to middle side. I'm making a ratio. I can make a ratio of anything. I can do Isabella to Jacob, okay, a ratio of heights. Okay, I can do all kinds of ratios. I could do males to females. I could do red cars to blue cars. Here I'm just saying small side to middle side. Okay? If I want to use that same ratio, small side to middle side of a triangle, what would that look like for this upper triangle here? If it's 3 to 4 down here, what would that be for the top triangle? What do you think? Don't be afraid to get it wrong. It's the whole part of learning.
Oh, wow.
You gonna take a shot?
No, take a shot.
Come on, give me a shot. Small side to middle side. I'm going 3 on top to 4 on bottom. So what would this one over here be? Three on top, 4 on bottom.
4 on top, 3 on bottom.
No. I can only, okay, fair enough. I said take a guess, and I appreciate it. Okay, but we're comparing it to this. The numbers have to come from the top triangle, okay, or the letters. So Gabby.
X on top, 6 on the bottom.
X on top, 6 on the bottom.
I didn't
Look, small side, middle side, middle side. What I've done is I've created a proportion. If I were looking at just this, could you solve it?
No.
Yes.
If I wasn't even looking at triangles, is this something that you are able to solve?
Definitely.
Yes.
Absolutely. You would do what? But yes, Noah Miller. This. Yes, tell me what that is. Cross multiplication. Yeah. You'd cross multiply these two numbers. Okay? Let's do it. 3 times 6 is what?
3 times 6.
And that's going to equal 4x. How do I get x by itself? Caitlin.
You divide both sides by 4.
That's right, I do. Okay. Now, this simplified is 9 over 2. 9 divided by 2 is what number? 4.5. So x equals 4.5. Okay? All right. So we've got that much down, and that's good. So now I know this is 6. I know this is 4.5. Now I want to know what the hypotenuse is. So here's what I want you to do. I want you at your tables right now to work with the people next to you and say, can we do something similar to what we did here to find the hypotenuse? Okay, try it right now. See if you can figure it out. If you get it wrong, okay, you do. But try it. See if you can figure it out. See if you can set something up to solve for what I will call y. Okay? Try it right now. Try it. And if you don't know where to start, ask the person next to you. And if they don't know where to start, okay, then at least draw the equal sign and the 2 dashes.
Do you know where to start? Equal sign.
There you go. That's not an equal sign.
Equal sign. 2 dashes.
This is your homework, by the way. They're going to give you pictures, and they're going to want you to draw proportions. Okay? So you have to be able to do this. So you have to actually work at it. It's hard. Yeah? Did you solve this? 18 divided by 4? You just got to finish the math. I can.
Oh no, it's 10:30. Math is no. I heard that in the time.
Wait a minute. Yeah.
I felt the wind going in my ear, and I felt the.
Yeah, that's great. Oh, yeah, that's a great place
It's
to
like
start.
a ball of air.
All right, let me start with setting it up, and then I will give you your homework, which I want you to try tonight. Okay? Shh, here. Gretchen was absolutely on the ball here. She said, if I need to find y, I've got to use this 5. So she was going to use 4 and 5. It doesn't matter what order you do it in. So let's just go ahead and do 5 over 4. I did the longest side over the middle side. Okay? So then that is going to be the longest side over the middle side. So what would that be here? Yeah, Gretchen. Not x over 6, but y over 6. Can you solve that? You can. Cross multiply, solve the math. That's it. You're just using the shape of the triangle and comparing. So here I did long side, middle side. Here I did short side, middle side. You just are trying to maintain the proportion. You're comparing sides of triangles.